In this video, we're going to use electrostatics to move electrons around and to charge these two cans. And you may remember doing this in class. I believe we did do this in class. Step one, we start here. We have two neutral soda cans touching each other. Now, we say they're neutral because if you count the positives on here, each will have 6 and 6 on each. This is how we normally draw a neutral object. Equal number of positives and negatives, and they're spread around the cans. These are neutral cans, they're touching each other. Next, we take a balloon, rub it against a sweater, and as you recall, negative electrons move to the balloon, and then we have a negative balloon to work with. Next, we move this balloon closer and closer and closer to these two touch cans. What's going to happen? Don't like charges repel? So wouldn't this negative repel those negatives there? They would if they could move. And can they move? Well, these cans are made of metal. They're conductors, aren't they? They have free electrons that can move. All right. So what happens? If you get very close without touching, what happens is all these electrons here are gone, aren't they? Where did they go? They were repelled. They were pushed. And since they were touching, these cans were touching, they could flow right into this can. And I've even got the negatives on this end of that can pushed away. All the negatives are piled up back here, weren't they? Because these are metal cans, they have free electrons, they can move, and of course that big negative charge there repels them and pushes them over here. And then, if you remember, to charge the cans, we just put our finger in here and we separate them very quickly. Now they're separate, and you'll notice now the balloon is gone, the positives and negatives spread out over here across the can, but there are many, many more negatives here, aren't there, now than there were before. In fact, more negatives than positives. This can has been made negative. This can here lost a bunch of electrons. It was neutral before, lost negative electrons. It becomes positive. And we have charged these two cans, positive and negative, by using the fact that electrons on conductors, free electrons, can move. The video code is charged cans. Charged cans. Now here's a good question. What if we try this again, but we replaced these cans with wood? You see two neutral blocks of wood. Would the same thing happen? I know you're thinking no. The question is, can you explain it well? Let's see if I explain it well. No. Wood is an insulator. There are very few or no free electrons to actually move around, so the electrons would not move. The electrons that are on wood are tightly bound inside the nuclei of atoms, so they can't be pushed around. So in fact, we could not charge two pieces of wood this way because they're insulators, very few free electrons, and so this guy will not move the electrons. That's it. Bye.